Today we're going to do another Friedel Crafts acylation reaction using propionyl chloride, but this time we're going to use toluene as the aromatic compound. We're also going to start with propionic acid and make some nice fresh propionyl chloride as an intermediate. For the first step we're going to prepare propionyl chloride, and to do this we're going to use a 100 ml flask equipped with a small magnetic stir bar. Here's 20 ml of propionic acid. It's important that the acid is dry and water-free, otherwise your yields are going to be terrible. Let's get this into the flask. Note that we carefully washed and dried all glassware for this reaction. It's important to keep water out. Here we go. We set up the flask on a water bath. We don't think this is going to be too exothermic, but it's a good safety precaution. In addition, if we spill anything it's going to get neutralized pretty fast by the water. We've put the stopper on here to keep moisture out while we prepare the next reagent. Okay, here's the good stuff. This is 8 ml of phosphorus trichloride. It's hard to get hold of, but a little goes a long way. There are some other sneaky ways to make acid chlorides, so watch our other videos to get some ideas. Get your ventilation on because it's toxic and gives off HCl fumes in moist air. We've got the thermometer in our propionic acid just out of interest so we can monitor the temperature. Okay, with stirring on and ventilation going, let's slowly add the phosphorus trichloride to the acid. We like it when things like this aren't exciting. The reaction is much slower than for acetic acid, and there's hardly even a need for the water bath in practice. We removed it and allowed the mixture to stir. There's a little bit of HCl gas being given off slowly, and to begin with the reaction mixture looks as though it's just one clear layer. The temperature has only risen by about 5 degrees C. But soon the mixture turns cloudy and we place a stopper lightly inserted into the flask so that any gas can escape, and we leave this to react and settle. After about an hour the lower layer of phosphorus acid, which is viscous and thick in consistency, is separated out. Here we are an hour later. The reaction is still going on, but we can set up for the next stage at this point. Prepare a thoroughly cleaned and dried ground glass jointed addition funnel. Make sure that the stopcock is nice and tight, and also closed before you add anything. Even we make this mistake from time to time. Pour in the reaction mixture containing our propionyl chloride. And now let the mixture separate so that all the phosphorus acid drops to the bottom. This takes a while to complete. Remove the bottom layer so you've got only the crude propionyl chloride in the funnel. Okay, now we can get set up for the main reaction. We're using the 500 ml 2-neck flask, and we've got this sitting on a magnetic stirrer with a cold water bath. You need good stirring for this reaction, so we've got a stir bar in the flask, and we've got the gas takeoff adapter in the side arm of the flask, leading to a calcium chloride drying tube. Again, we cleaned and dried all the apparatus carefully. Now for our solvent, an aromatic reagent. We've measured out 75 ml of dry toluene. The reaction itself requires about 28 ml in theory at maximum yield, so this is a good excess. This goes into our reaction flask. And we've got this stirring away vigorously. Now for our catalyst. Here we have 36 grams of freshly prepared anhydrous aluminum chloride. You can check out our video for details of how to make this, but very briefly, you strongly heat a fine and well-mixed mixture of anhydrous zinc chloride and aluminium powder, and condense the product in a cooled receiving bottle. Best results are obtained when you use exactly a 5-to-1 weight ratio of these. This goes into the flask with the toluene stirring. If your toluene is dry, then there should be no temperature change, although we get an interesting yellow-orange color forming. Now place the addition funnel containing the propionyl chloride on top of the flask. Fill the water bath with water. We're using water at room temperature. And now we start the addition. Try to go slowly. As the propionyl chloride drips in, hydrogen chloride gas is generated and escapes from the drying tube. Let the addition continue slowly over the next 30 minutes. The color of the mixture first changes to a brown color. Then towards the end of addition turns green. Everything is now added, so we've closed the stopcock and we're now going to leave the mixture stirring so that the reaction can complete. There wasn't much of a temperature increase both during the reaction and after, so we removed the water bath and allowed the mixture to stir for the next 2 hours. It became quite viscous and a very dark brown color, as you can see. We're going to prepare our quenching mixture now, which is 125 grams of ice and 10 ml of concentrated hydrochloric acid. This prevents aluminium hydroxide from precipitating out and creating a big mess. So now we slowly pour in the reaction mixture. A lot of HCl is produced, so be very careful. On swirling, the dark color hydrolyzes and disappears, leaving an orange-colored top layer of toluene and our product. There's an interesting sweet propiophenone-like aroma. The first thing we need to do is separate off the organic layer, so we place the mixture into a separating funnel. Allow the layers to separate, and then remove the bottom aqueous layer. But keep it, don't throw it away yet. Here's our organic layer, so we transfer this into a flask and reserve it. Now we're going to put the aqueous layer back into the separating funnel and we're going to extract it to make sure we've got all the product out. Here's another 10 ml of toluene. We shake and then let the layers separate. Then discard the aqueous layer. And then add the organic toluene layer to our other one in the flask. Okay, here's our toluene solution of our product, with some water in here, and probably some side products as well. There are a few options now to purify, but firstly we're going to set up for distillation and we're going to remove the toluene from the mixture. So let's get the product into a flask. And we've set up for simple distillation. We're using the thermometer to check the vapor temperature, but our product boils at over 200 degrees C whereas toluene at around 110, so it should be easy to see the difference. Here's our toluene coming off. Distillation was pretty rapid and only took about 20 minutes for all the toluene to come off the mixture. Here we go. It's milky colored because it contains some water, but we'll dry this and recycle it. Here's what left in the boiling flask. An orange-colored quite viscous oil. This is our crude methylpropiophenone. We let this cool down. The product boils at nearly 240 degrees C and we don't have a vacuum facility suitable to distill this. So instead we're going to try to steam distill. Here's around 150 ml of water. We add this to the cooled crude product in the flask. It's a pretty funky looking mixture. And now we reheat again and distill. The water will first bring over any remaining toluene, and then hopefully our product. If it can be steam distilled, that is. Here we go. We discarded the first 10 ml or so of distillate as this contained toluene. And now we've got something a lot more viscous seemingly coming over with the steam. So we collected this. All was going well with the distillation and we collected the first part of the distillate and then topped the flask up with about another 100 ml of water. And then, disaster struck. We didn't catch it on film, but it seems as though the water and ketone mixture is able to form an extremely superheated mixture. The result is that suddenly, without warning, half the contents of the flask boiled in about 1 second with the same force as an explosion, shooting our thermometer into our extractor hood. The results are painted on the walls. We've seen extreme bumping and superheating before, but nothing like this. As an experiment, we took the remaining mixture and heated it under controlled conditions with anti-bumping precautions. The exact same thing happened. So this is a warning. Do not attempt to steam distill this ketone. We did, however, save the first portion of the steam distillation, which was quite slow. There's a bit of product in here. So we extracted this using 10 ml of dichloromethane, then we removed the bottom VCM layer, and evaporated this down on the hot plate in a pre-weighed container. So here we go. We did salvage 2.3 grams of product, which is the pure sweet-smelling for methylpropiophenone, possibly containing some ortho-substituted product as well. Technically the yield is only 6%, but we've learned a lot on the way. We made up a saturated solution of sodium bisulfite in water and added the ketone. But unfortunately, like propiophenone, it doesn't form a bisulfite adduct, which rules out another method of purification. So if you want to make this pure, then you are going to have to get a good vacuum distillation kit, or risk 240-degree heat on the ketone. Otherwise this is as pure as you can get. Thanks for watching and stay tuned.